right. We also see that we get the wind speed and wind direction from this. Okay, so that helps us determine which way things are going to move within the atmosphere. But as far as moisture goes, what we're able to do with this information is calculate what we call precipitable water, which is the amount of moisture in the air. And if we were able, or if Mother Nature is able to squeeze it all out, at one time or over a period of time, we would get, less than that usually, because 100% efficiency is kind of hard to come by. So we know kind of what the maximum amount of rainfall from a single storm might be. But again, if the storms repeat over an area, what we call training, we may get more than that. But 1-2 inches of rain, possible is something there. Okay. Now, the amount of evaporation that can take place can be really significant. People that have swimming pools in the middle of summertime are probably adding water every day to their swimming pools because they may be losing an inch or more. All right. So if you think about that on the lakes and stuff, and the ocean, if you evaporate an inch of moisture off of all those surfaces, that's putting a lot of moisture and energy back up into the atmosphere. Okay? So now we're going to switch over to our next phase here, and that's condensation. Okay? So all those little droplets of moisture start coming together and sticking to each other, and maybe they form a cloud. Over here we're looking at this waterfall. All right, so we have liquid water that's hitting the ground, splashing back up, and some of it sticking together. You can see kind of the fog and stuff in there. So it's not really condensation per se, but it's a very good example. You got that cloud up there. All right, that cloud came from most likely this water vapor. Could be on the ground there that's floating back up there, and as you move up in the atmosphere, the air cools, and we start getting condensation. So that dew point temperature gets lower. The atmosphere becomes more and more saturated. All right, and I'm sure that a lot of you are familiar with what we're going to see here on our next slide. Here, we got a couple examples of some condensation that happens quite frequently in our area here. You take that glass of iced tea out on the porch, and you set it down, and you can see, if you look closely here, there's some little water droplets on the outside of the glass, and you can even see on the napkin down here, there's some more water spots. And what's happened is the surface of the glass is cold enough or below the dew point that when the air contacts it, the moisture in the air condenses onto that surface. All right, and you can see over here on the picture on the left side here, all the ice is gone here, but that napkin is puckered quite a bit, and a lot of moisture has gone into that napkin. So condensation is the moisture in the air coming back together. Okay. Now I got another little video here. We're going to come up. We're going to make a cloud in a bottle.
Okay, folks, we're going to make a cloud in a bottle. So I just have a simple 2-liter bottle here. All right. Now to make a cloud in a bottle, we need to take the moisture from the air. To increase the relative humidity within the bottle. So I have a little air pump here, just a tire pump from bicycle. Every time I push the cylinder, the air forces it through the tube, and we're going to put more air and more moisture into this bottle. Now, the way this is going to work here, I'm just going to put this over here. Nothing special about this pump or anything. I just got a good system over here for making a good seal on there. And it gives me 20 pumps. And then when we decompress it, when you decompress a gas, it cools. Right? didn't get the cloud to form. So we're going to do a little trick here. And I'm just going to add a little rubbing alcohol into the bottle. It's going to do a couple things. I'm going to try to evaporate some of it in here also, just by spinning it around. Just like when you get a shot at the doctor's office and they use a little alcohol to clean your skin, it feels cool when it evaporates. So it's even going to cool the temperature inside this bottle even further. Okay? And again, we're going to put the tube up there, and we're going to see what good. And 20 and all right. So we cool it. You can maybe see some of the movement in there and stuff as it kind of warms up. It immediately starts to dissipate and everything like that. So we also added, by adding the alcohol, that gave it also called condensation nuclei. That's something for the water vapor to condense onto, all right, which is very critical because sometimes you may have some very moist air, but there's nothing for the water to condense onto, so you actually don't get clouds or fog to form.
Okay, now we're gonna switch over here and talk about the next part of that, which is the precipitation cycle. And once you get the condensation in there, as those molecules or the droplets run into each other, they kind of start sticking, and eventually they will grow big enough that the updraft cannot suspend them anymore, and then they start to fall out. And so we deal with lots of different types of precipitation. We're going to take a look at a few of them here and kind of go over what they are. And some of them are very, very interesting, you know, in the way they function and stuff. You know, everybody is very familiar with your regular rainstorm. You know, we get rain and it varies in the intensity of it. You know, sometimes we can get, you know, like I said, I got 2 inches of rain over several hours the other night, you know, from some rainstorm. But, you know, it can really vary a lot. Matter of fact, one of the other types of precipitation that we deal with is drizzle, which is very small, okay, almost suspended. You know, if you watch drizzle come down, sometimes it looks like it might be going up, all right? Another thing that we get in our part of the world is hail, all right? And hail is basically frozen precipitation, all right? And we also deal with snow. Now, snow is frozen precipitation, but snow starts off as a little ice crystal in the atmosphere and floats down to the surface, okay? But hail might start off as a snowflake. It might start off as a water droplet, but it gets bounced around and recirculated in the upper atmosphere by you know, updrafts and downdrafts, and it can grow to be very, very large, all right? And then we have some ice pellets or sleet, which are kind of smaller things there. But another phenomenon we have are ice crystals, all right? And we don't see those down here very much at all. You know, it's usually really, really cold for ice crystals to form and be in the atmosphere like that. But there's very much, you know, it's kind of like drizzle, except for in a form of a pure ice crystal and stuff like that. So now we've taken, you know, the water cycle from evaporation through condensation and precipitation. Now, one of the things that, you know, several years ago, I met a elementary teacher at a science fair, and she showed me a water cycle song. And so we're going to go through the water cycle song once here and see if we can get this to go. Okay, so if you guys know a water cycle song and want to post it for us, that would be great. We'd love to hear you and see you posted on our Facebook page there. We're coming to the end of the program now. There's a couple things. Like I said, at the end here we have some links to different sites you guys can check out to get some information. On one of them, we have some different things you guys can make here and stuff. Let's see if we can get this to work. Okay, so I'm just going to hold this up like this. This is a little diorama that describes the water cycle and stuff. And if you guys can cut that out and tape it together and stuff like that, you wind up with something like this here. And it shows you how the water cycle works and stuff. And then, like I said, if you want a cyclometric calculator to help you figure out what the humidity is in your area, that's also on these websites. One of the things that we've done here is we're going to post in the comment section a word search, so you guys can download that and go through that and see how you do with that, just to kind of give you a little more challenge and give you something else to fill the day with and stuff. But other than that, we have kind of finished our program for today. I'm going to go ahead and pull up the next slide here. And this again is the links to several of the sites that we did here. Once we're done with this video, we are going to post it up on our YouTube site, so you guys can search for it and tell your friends about it if you thought you liked it and they might enjoy it, and we'll get it going that way. So we are all good to go here, and here are those links. And they're going to come up here in just a second on the stream and stuff. There are several different programs we really want to encourage you guys to go back out and look at to see and learn more about the science of weather and stuff like that. We do this as part of our living here, and we really enjoy it, and we love telling people about it. With the things that we have going on right now, we're doing a lot of virtual things like this through Facebook Live to reach out to people to help try to educate them. It is summertime, so we don't have any tours going on or anything like that of our facilities because of the COVID stuff. And one of the things that we had talked about earlier, in conversations, people have been talking about the Sahara deaths. And that's one of the reasons, and again related to the water cycle, there's a lot more dust in the air. So there's probably going to be a lot more clouds because there's a lot more of that condensation nuclei out there for the moisture to stick onto and stuff. So, again, if you have any questions or comments, please go ahead and post them here. We're going to go ahead and end the video, the live feed here, but we'll be around for a little bit longer as we kind of clean up and get ready. Next week, Saturday, is July 4th. And we're not going to do a program on July 4th just because it's the holiday. But the following Saturday, which should be the 11th of July, if I have my calculations right, we're going to do another program here, and we're going to be focused on lightning. If there's any subject matter that you guys have an interest in, please let us know. Comment on our Facebook page, and we'll try to cover it as long as it's related to weather. We've got some other topics already. We're going to talk. We've got a future one for radar. We've got a future one for hurricanes. We've got a future one for talking about temperatures and all the different types of temperatures that are out there and what they mean and how they impact us and stuff. So, if there's some other topic, if you want to learn more about tornadoes, let us know, or maybe snow, and that type of stuff. We're more than willing to come up with a program for you guys and try to adjust any questions you might have. So again, my name is Mario Valverde. I'm the meteorologist in charge of the National Weather Service here in Shreveport, Louisiana, and we will be looking forward to interacting with you guys in the future. That's it for us today. Thank you very much.